Kind of crazy, huh? No matter what your rational point that you're trying to hit, if you're shooting with an irrational slope, you'll never hit it. And if you're wondering why that's true, let me walk you through a little example. Suppose the rational point, the fractional point that you're trying to hit, was a half comma a half. Well, what would that mean? That would mean that you're trying to hit the center of the square, or the center of one of the squares on the whole big thing.
What about the point, say, this point here that's a half comma a half? Will it hit that point?
No, I don't think so.
Why not?
Well, because, like, for
it to hit that point.
So say I had to go out a kabillion ways across to get to that square that it's going to hit the middle of. What would happen if I went out 2 kabillion?
It would hit here, but then that wouldn't work.
No, where would it hit?
It would hit the. Wait, if it gets halfway through, then
If it
2
gets
kabillion, it's going to get twice as far up and it's going to hit there, so that's not possible.
Does that make sense?
You're trying to hit the center of the square on your little video game screen, which is the same as having your big line run through the center of one of the squares out there.
On our big graph, getting halfway and halfway corresponded to going out a kabillion places across the x-axis and some number up the y-axis, but then if we went out twice as far on the x-axis, that would take us twice as far, so we'd actually hit one of those top corners.
And so where do we end up? We end up on a grid point. And if it goes through one of the grid points at any stage, then that means that that line has rational slope. Can't have rational slope. We shot with an irrational slope line. So we get a contradiction. Let's reiterate. If I'm shooting with a line with irrational slope, I won't hit any rational points. Sure, I can find a point that has a rational x-coordinate, but then the y-coordinate won't be rational. Or I could have a rational y-coordinate, but then the x-coordinate won't be rational. I cannot find a single point in that little video game square that has rational x and rational y coordinates.
So that's kind of amazing, right? Like on the one hand, it gets denser and denser and denser, and it keeps looking like it's going to fill this whole square.
And it never does.
And on the other hand, not only does it not fill the whole square, it actually misses any point on the square that has a rational coordinate here and a rational
Which
coordinate
it
there.
sounds crazy.
So it kind of
because,
misses most of the points on the
But
square.
then that means there are a lot of. But it would be like.
Can you see why the Greeks decided to put someone to death over this?
Yeah.
Their minds were probably melting.
It misses every rational point. That's a lot of points that it misses. There's a way of looking at this where you start to realize that not only does it miss all the rational points, it actually misses almost all the points. But that's kind of for another time. We're straight a fair way from spot it right now. And besides, if this is the first time you're hearing this, your brain's probably melting out your ears right now. So you know what? Let's do what mathematicians do. Let's simplify again. Let's go back to the 80s. Let's go back to a time when your video games, you could see all the dots on the screen.